Ever looked up at the night sky and thought, wow, those stars must have been there forever, right? Well, turns out, the universe is a bit more dynamic than that. Stars, those twinkling beacons of light in the sky, aren't just static fixtures. Nope, they're born. They live their lives, and eventually, they bid us farewell. Sometimes in the most spectacular way imaginable. Now picture this. Imagine the vastness of space, filled with swirling clouds of gas and dust called nebulae. These clouds aren't just random fluff. They're stellar nurseries where new stars are born. Over millions of years, gravity starts doing its thing, pulling these gas clouds tighter and tighter until they collapse under their own weight. It's like watching a cosmic dance with particles swirling and clumping together until, bam, a star is born. But stars aren't immortal. Like everything else in the universe, they have a life cycle, and it's far from boring. You see, stars shine bright because of nuclear fusion, a process where hydrogen atoms smash together to form helium, releasing a ton of energy in the process. That's what's been keeping our sun going for billions of years. It's basically a giant, glowing ball of hydrogen gas, churning out energy like there's no tomorrow. But eventually, all good things must come to an end. Stars, like our sun, will eventually run out of hydrogen fuel. When that happens, they start to swell up, becoming what's known as a red giant. It's like watching a cosmic balloon inflate, only instead of helium, it's puffing up with helium and other heavier elements. Now, for smaller stars like our sun, this is pretty much the end of the road. They'll shed their outer layers, forming beautiful glowing nebulas and fade away into cosmic oblivion. But for the really big stars, the ones that are tens or even hundreds of times the mass of our sun things, get a lot more dramatic. You see, these massive stars have been burning through hydrogen like there's no tomorrow. But once they start fusing heavier elements like silicon and iron, things start to get messy. Iron fusion is a bit of a dead end. Instead of releasing energy like other fusion reactions, it actually sucks it up. So while the star's core is collapsing under its own weight, the outer layers are still trying to push outwards. It's like a cosmic tug of war, with gravity pulling in and radiation pushing out. But eventually, gravity wins out, and the star's core collapses in on itself. This is where things get really interesting. The collapse happens so fast that the star's outer layers can't keep up. They come crashing down on the core, compressing it even further until, kaboom! The whole thing explodes in a spectacular supernova. Now, when we say explode, we're not just talking about a little pop. We're talking about a cosmic fireworks display that puts anything we've ever seen on Earth to shame. These explosions are so powerful that they outshine entire galaxies, lighting up the cosmos for months on end. One star that's been getting a lot of attention lately is Betelgeuse, the bright red star in the constellation of Orion. It's nearing the end of its life, and astronomers think it could go supernova any day now. Well, any cosmic day, that is. When it does, it'll be so bright that you'll be able to see it in the daytime sky. But as impressive as Betelgeuse's impending explosion might be, it pales in comparison to the most energetic supernova ever recorded. In 2016, astronomers spotted a supernova event that was so powerful, it made everything else in the universe look dim by comparison. We're talking about an explosion so bright that it outshone entire galaxies. And that's no small feat. But what causes these massive explosions? Well, it turns out, it's not just the collapse of the star's core that's to blame. In some cases, a shroud of gas surrounding the star can get blown away by the stellar wind before the supernova even happens. When the explosion finally does occur, this gas gets caught up in the shockwave, releasing even more energy in the form of electromagnetic radiation. So, there you have it, folks, the incredible, awe-inspiring spectacle of supernovae. From the birth of stars in swirling nebulae to their explosive deaths in brilliant bursts of light, the universe never fails to amaze us with its cosmic wonders. So next time you gaze up at the night sky, just remember, those stars might seem steady and unchanging, but they're anything but. Hey, space enthusiasts! Ever wonder what would happen if a supernova, one of those cosmic fireworks shows, decided to go off a bit too close to home? Well, buckle up, because it's quite the cosmic roller coaster. Normally, supernovae happen far, far away in distant galaxies, and we're just here on Earth, admiring the show from a safe distance. But what if one happened right in our cosmic backyard, say, within about 33 light-years from us? Well, let's just say it wouldn't be pretty. You see, when a star goes supernova, it releases a ton of energy, much of it in the form of gamma radiation. Now, most of the time, by the time these gamma rays reach us, they've lost a lot of their punch, so we're in the clear. But if a supernova happened nearby, it'd be a different story. First off, there'd be virtually no warning. One day, we'd just wake up to a deadly wave of gamma radiation hitting our atmosphere. And that's when things start to go south. The fragile ozone layer, which shields us from harmful cosmic rays, would start to break down, leaving us exposed to all sorts of nasty stuff like cancer, genetic mutations, and other radiation-induced illnesses. Yikes! But wait, it gets worse. The global climate would take a hit too, with temperatures rising by a few degrees Celsius. This might sound like no biggie, but trust me, it'd wreak havoc. Ocean levels would rise, climate disasters would become more common, and delicate ecosystems like coral reefs and phytoplankton populations would be decimated. In fact, there's evidence to suggest that something similar happened around 450 million years ago during a mass extinction event. A nearby supernova might have been to blame, wiping out a whopping 85% of marine species on Earth. Talk about a bad day for ocean life. Ever pondered what might happen if a supernova, one of those grand cosmic explosions, decided to go off a bit too close to our cosmic neighborhood? Hold on to your helmets, because it's time for a wild ride through the cosmos. Typically, supernovae are distant celestial spectacles, lighting up galaxies far, far away, while we Earthlings watch from a safe distance. But what if one of these stellar fireworks happened to pop off nearby? Let's say within about 33 light-years from our cozy planet? Well, let's just say it wouldn't be your average stargazing experience. Picture this. A star goes kaboom, releasing a burst of energy, including a hefty dose of gamma radiation. Now, usually, by the time these gamma rays reach us, they've mellowed out a bit, posing no real threat. But if a supernova exploded within shouting distance, it'd be a different cosmic ballgame altogether. First off, there'd be no heads up. One moment we're sipping coffee, the next, we're hit with a blast of gamma radiation. And that's when things start to get dicey. Our protective ozone layer, which shields us from cosmic rays, would start to crumble, leaving us vulnerable to all sorts of cosmic nasties like cancer and genetic mutations. Not exactly a picnic in space, huh? But hold on to your rocket boosters because it gets even more dramatic. The global climate would go haywire, with temperatures shooting up by a few degrees Celsius. Sounds minor, but trust me, it's a big deal. Sea levels would rise, extreme weather events would become the new norm, and delicate ecosystems like coral reefs and ocean plankton would take a beating. Believe it or not, there's evidence suggesting this isn't just science fiction. Around 450 million years ago, a supernova might have been the culprit behind a mass extinction event, wiping out a staggering 85% of marine life on Earth. Talk about a cosmic catastrophe. But before you start building your underground bunker, here's a silver lining. Near-Earth supernovae are about as rare as finding a shooting star in broad daylight. We're talking once in a few 100 million years rare. So, odds are, we're in the clear, at least for now. But here's the kicker. Despite their destructive power, supernovae are also cosmic alchemists, cooking up elements heavier than iron in their explosive kitchens. These heavy elements, like uranium, eventually find their way into new stars and planets, including our very own Earth. But hey, before you start losing sleep over a supernova apocalypse, here's the good news. These events are incredibly rare, especially ones close to Earth. We're talking once every few 100 million years rare. So yeah, odds are we're safe. For now, at least. But here's the cool part. Despite their destructive power, supernovae also have a pretty neat trick up their sleeve. You see, when a star goes supernova, it releases a burst of energy so intense that it can create elements heavier than iron, stuff like uranium, for example. And guess what? These elements eventually find their way into new stars and planets, including our very own Earth. So, while supernovae might seem scary, they're also responsible for creating the building blocks of life as we know it. Pretty mind-blowing, huh? Thanks for joining us on another cosmic adventure. If you enjoyed this video, be sure to check out more fascinating space content. Just click on the video on your screen. Until next time, keep looking up. If you enjoy our content and would like to stay updated, we'd be thrilled if you could hit that subscribe button. It would mean the world to us. Thanks for your support.